Let us look at proposition number 18 of works of Archimedes, specifically from on conoids and spheroids. The proposition says any spheroidal figure which is cut by a plane through the center is divided both as regards its surface and its volume into two equal parts by that plane. So let's say we have a spheroid centered at A. Take another equal and similar spheroid with center at B. Let a plane cut the spheroids through the center. Now, what this plane will do is it will form a intersection with the spheroids. So let's mark these intersections. So now this sphere has been cut into two parts, one above and one below the ellipse of intersection. And same is the case here as well. Cut a slice of the first spheroid top half and a slice of equal width of the second spheroid bottom half. So we actually cut it with a plane, but I'm not going to show those planes because we will end up with too many planes then. Another plane cuts this top half by a width. So we end up with a slice of this top half of the spheroid. Now we cut a slice on this spheroid bottom half of equal width. Put the slices on the opposite sides of a fulcrum at equal distance from the center. Then their moments will be equal. So here we'll have to build up a fulcrum with a plank on that. So let's build that. Now, if we put this slice on this side, where the center of this slice matches with this point, and similarly we put this slice so that the center B is on top of this point, then their moments would be equal. Now this is based on the law of the lever. If equal weights are placed at equal distances from a fulcrum on opposite sides, the beam remains balanced. Now repeatedly cut slices of equal width and put on the lever. So we take another slice from here and put it on that lever. The corresponding slice we take it from this and put it on the other side. Again it balances. Again we cut another slice from both and put it on top of the opposite sides of the beam. Similarly, these two. Similarly, these two. Similarly, these two. So slice by slice, we have seen that they balance out each other. So each slice of the first spheroid and the second spheroid will be equal. Remember, first slice of the first spheroid top half and the slice from the second spheroid bottom. So the sum of the slices of the first spheroid top half will be equal to the sum of the slices of the second spheroid bottom half. So now the spheroids are equal. We are given that. Take another equal and similar spheroid. So the spheroids are equal. Top half of one is equal to bottom half of the other, which implies that the bottom half of the first is equal to top half of the second. Since the corresponding halves are equal, it implies that the top and bottom halves of the given spheroid are equal in volume. See, the whole thing is equal to the whole thing. Top half is equal to the bottom half. That means the bottom half is equal to the top half. And similarly, the surface area is also bisected. This method of slicing and comparing the slices is called method of application. And here moment, see here their moments would be equal. Moment is equal to force times distance from the fulcrum. Now, why not use slices from top and bottom half of the same object, same spheroid? Because at the time of Archimedes, the definition of weight was the heaviness or lightness of one thing compared to another as measured by a balance. So to stick to this definition, he had to come out with another object. Since he wants to do a like to like comparison, that is why he took another equal and similar spheroid. That is proposition number 18 of works of Archimedes, specifically from on conoids and spheroids. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now. Bye.